Hello friends, welcome to Risingpearl.com. Today we are talking about series 12 where we are learning a great deal on areas related to circles. Friends, this is our webisode number 9 and today we are going to focus on solving questions on areas of combination of plane figures. This is part 1 because over the course of maybe 2 or 3 webisodes we are going to cover this topic of how to solve questions on areas of combination of plane figures. So friends, first let's take a look at our strategy, how actually we approach such questions. So the first very important step is that try and see which simple figures such as triangles, circles, sectors, squares, rectangles, regular polygons, so on and so forth, that make up the given complex figure. In other words, you take a look at the complex figure and try to break it down in terms of simple figures, right? Simple figures meaning triangles, circles, sectors, squares, rectangles, polygons, etc. The second step to solving these questions is that find out which areas need to be added or which areas need to be subtracted to get the required area. Sometimes you may need to add 2 or more areas to get to the desired area which is being asked in the question. Sometimes you may need to add 1, 2 and 3 but then subtract 4 and 5 to get to the required area. So understand which areas to be added, which areas to be subtracted to get the required area. And then finally the last step is that you actually find the areas of the individual simpler figures using the formulas that we have learned earlier in the series and even in our earlier grades. And then from there you calculate the required area by simply plugging in these values of individual areas into our step 2. Right? So these are the step-by-step ways of how we approach such questions. So let's quickly recap. First, try and visualize which simple figures make up our given complex figure. Second, which is also very important, is to make sure that we understand which areas to be added and or subtracted to get the required area. And third really is apply the formula, find the areas of the individual simpler shapes that you have broken down your given figure into and calculate the required area based on what areas we should add and what areas we should subtract. So with these 3 steps in mind, friends, let's take a look at some of the questions. So this is the first question. In the figure below, 2 circular flower beds have been shown on 2 sides of a square lawn ABCD of side 56 meter. So we have a square lawn ABCD and now on the 2 sides of it, so we have 2 circular flower beds on 2 sides of a square lawn. So ABCD is a square 56 meter long. So ABCD is a square whose side is given 56 meter. And this one, AB and DC or CD are 2 circular beds as shown on 2 sides of the square lawn. Now there is one important condition which is given, which is that if the center of each circular flower bed, if the center of the circular flower bed, it is the point of intersection O of the diagonals of the square lawn. So essentially we draw the diagonals AC and BD of the square lawn. They intersect in point O, let us say. Then O actually is the center of the two circular flower beds. That means that taking OA as the radius, we draw a arc or part of the circle and we get this. Similarly, taking the same R as radius, we draw this part of the circle. So it's important to understand. So the question is asking, find the sum of areas of the lawn and the flower beds together. So we have to find out basically the whole area. So what from our first step, what you should be able to clearly see is that the required area, which is what we need to find out, we can think of this as, this can be thought about as equal to area of the square ABCD, right, plus it is this part. That is what we need to find out. So this is a segment. So from this clearly we should be able to see that one way to go about this is that area of the entire square plus two separate areas. So area of the square ABCD plus area of the segment AB and CD. So if we can find the areas individually and then simply add them, we will get a desired area, right? So let's figure out how do we go ahead and solve. One other way to also think about this is that if you think that you do not want to deal with segment, right, then what you could also do is you can, so let's first write down what we just talked about, right? I think it will be important. So the desired area or the total area will be equal to area, I'm writing AR, short form for area of square ABCD plus area of segment AB plus CD. So this is one way to write the total area. But if you don't want to write it in terms of the segment, you could also write the total area as, let's give ourselves some more space. So this is the first way of writing. The second way of writing the same area, which is the total, is that you can think about this as area of the entire sector. So we have two sectors here, right? So if we add two sectors, then to the sector we add half the area of the square, because the total will be this plus this and this, but this and this together is only half of the square. That means if we take this and then add this and this and this is going to be put together only half of the square, because the square, if you draw a diagonal like this, it divides the square into two equal parts. If you draw another square, another diagonal, so these are all equal parts of a square. You can prove that if you draw a diagonal of a square, it divides the square into two equal parts. If you draw the other diagonal, now you have four equal parts. So if I want to use the sector, the entire sector as highlighted here, then I need to add half of the square. So in other words, we can say that it could be, then instead of saying area of segment like this, we can say area of sector OAB plus area of sector OCD plus half area of square ABCD. So there are different ways in which we can actually accomplish our desired goal. So why don't we do this? I think maybe it will be easier if we just use the second approach. But you know what, let me show you how you're going to use the first one, because whenever we get a chance to see how to find the segment, it is the more difficult approach, and if I can actually show you that, if you're confident in that, you can easily find the other one. So let's clean this up. So this is the first things first. So we have the square, which is 56 meter, which is given to us. Now we have not been given the radius. We have to figure this out. So if this is the radius, this is the radius, this is the radius, this is the radius. So if we look at triangle, let's say we look at triangle ADC. So if we look at triangle ADC, we know that this is 90 degrees. So applying Pythagoras theorem, from here we can see that if you apply Pythagoras theorem, so then r plus r, this is the hypotenuse, right? So 2r square should be equal to AD square, which is 56 square, plus CD square, which is 56 square. Or what we have is, this means it will be 2 times 56 times 56. So, or from here we can say that now 2r, so it will be 4r square. 4r square is equal to 2 times 56 times 56. Or from here we can say that r square, so let's cancel out 2, so 4, so we will have, so 2 2's are 4, so we have 2 over here, and we can actually take this out, so 2 28's are 56, so this can be 28 times 56. So r square is equal to this, or we can say r is equal to square root of, let's do it here, so we have 28 times 56 can be written as 28 times 2, or so 128 comes out, it will be 28 square root 2. So the radius is this much, 28 square root 2. So now that we have found the radius, we can simply 28 square root 2. So at this point we can very simply plug in the value. So for area of the square, right? So okay, alright, so we talked about doing the first approach, right? We want to do the area of the square. So we want to say this is equal to area of the square plus the segment. That is what we are doing. So the area of the square, alright, so let's see. So let's give us a little bit more space here. So this is equal to area of the square plus this. So now, so area of square ABCD is equal to, simply we know that if this side is 56 and this side is 56, because all sides are equal, so it is simply 56 times 56. So area of the square is quite straightforward, it is 56 square. As I have mentioned to you earlier, throughout this series, we try to let the computation stay with us till the very end. That is, we don't try to go ahead and find out all of the products, at the beginning. And the reason behind that is, if we keep them till the very end, there may be an opportunity for us to take some common factors and cancel them out. So the big numbers which we see are very big in the initial stages of the question. As we proceed through step by step, maybe once we take the common factors out, towards the end they may become much smaller numbers, and so easier to perform our computation on them. So area of the square, we have found out 56 square, and we have also seen that the radius is equal to 28 square root 2. Now the next thing is we have to find out the segment. Now keep in mind, the segment, we can think about that as the whole sector, right? And remember, the diagonals of a square, they intersect at a right angle. So this basically is 90 degrees, and this is 90 degrees. So the sector, so if you take a 90 degree and a 90 degree, it's half of a circle, right? So keep in mind that the area of a sector, we know the formula for that. It is pi r square by 360 times theta. If theta is 90, so 90 divided by 360 is 1/4. So this is 1/4 of a circle, this is 1/4 of a circle. So if you combine, it will be half of a circle, right? And so let's do one thing. So now let's see if we can move all of this out. So this is equal to this. This area is 56 square, and this, now let's write out. So this one will be how much? So this part, so we want to find out the segment, right? So the segment area for the segment, right, AB, so this one will be equal to area of the entire sector, which is going to be pi r square. R is 28 square root 2 pi r square by 360 times 90, right? Then we have to subtract area of the triangle ABCD, that is we have to subtract this. So now area of triangle, so we are actually looking to subtract this part out to find the segment. From the sector we are taking the triangle out. But what is the triangle? Triangle is 1/4 of the area of the square. So in other words, triangle is nothing but, it is 56 square by 4. So if one segment is this, right, if the first segment is this, the other segment will be simply this times 2, right? So if the first segment is this, the other segment is simply this times 2. So that means we have now found out this area and this area, and to this we add 56 square. So this is going to be a final answer. So again, we found out the entire area of ABCD. We found out what is the radius using this condition that if the center of each circular bed is the point of intersection of the diagonals of the square lawn. Using this condition, we found out the value of R. Then we found out the area of the square. We found out the area of the segment. So if one segment AB is this, so both segments, segment AB plus segment CD, both combined will be this times 2. And then we added the area of the entire square to this. So this is going to be a required answer. So friends, I am not going to be doing the actual computation for you, but I think from here you see just simply by solving this you are going to get the right answer. Now let's take one more example. So here question number 2, find the area of the shaded region in the figure below where ABCD is a square of side 14 centimeter. So what is given, friends, is we have a square ABCD and looks like we have 4 circles inside it. So we need to we are asked to find the area of the square, which is highlighted in blue color. So now when you look at this, the first thing that your mind needs to see is that simply we can find out the area of the required area by thinking that how about we actually take the entire area of the square, which is highlighted in blue, and then simply subtract the area of the circle, right? Because we have 4 circles, 1, 2, 3, 4. So if we calculate the entire square, area of the entire square highlighted in blue, and subtract the area of 4 circles, each circle is like this, so 1, 2, 3, 4, then I get our required area. So this is what we meant by the first step, where you must be able to break down this shape in terms of square and circles, and the second step, which is to say that the area of the required area should be equal to area of the square minus area of 4 circles. Now once we have done this, it really becomes very easy, because at this point what we can see is that, so let's do one thing. So what is, let's see, so at this point you should be able to see that the sides are given as 14. So if this is 14, So our area is going to be area of the square minus area of the 4 circles. Now, so each of the sides are 14 because this is a square. Now you should be able to also see that if you draw a diameter of one circle plus diameter of a second circle, then because the circles are touching each other, so if you draw, the circles are touching each other and also the outer edges of the circle are touching the square. So if I draw a straight diameter for the first circle, let's call its diameter D, and if I look at the diameter of the second circle, which is D, so what is given is that D plus D is equal to the length of the side of a square, which is 14. Or from here we find out that twice D equal to 14 or D equal to 7. So the radius will be equal to 7 by 2. The reason this is important is because I need to find out the area of a square. So I know that area of a square is 14 times 14 because each side is 14. That we can easily find out. But for this we need to find out the radius. And the clue for this is given right over here. The fact that the circles are touching each other and outer edges of the circle are touching the square. So that means this length D plus D should be equal to 14. And this condition gives us the radius 7 by 2. So now that we have all of these, we can simply put the values in and find out the desired area. So this area of the square is 14 times 14. So 14 squared, we actually know this, it is 196, right? Now, so let's do one thing. Let's give ourselves some space and write. So we have this radius. So this is 196 centimeters square. Now R, so we have this is equal to this minus 4 areas of circle because there are 4 circles. So I have to subtract 4 circles. Now area of a circle, area of one circle is equal to pi r square. Pi is 22 by 7 times r square. R is 7 by 2 times 7 by 2. Or in other words, we can actually 7 cancels out, 2 11, so 22. So we have, so this will be 77, so 11 and 7 77 by 2. So now we have to find out areas of 4 circles. Because we want to subtract out areas of 4 circles, it will be simply this times 4. So it will be 2. 2 2s are 4. So 77 times 2 will be equal to, so 2 7s are 14, 1 carry over, 14 and 1 15, 156 centimeter square. So areas of 4 circle is 154 centimeter square. That means our required area is equal to, so this one is 196 and 4 of this, so this remember is equal to this minus 4 of this, so it is 196 minus 154, or if you just subtract it, 196 154, so you get, this is 2, this is 4, so 42 centimeters square. Let's just make sure we did it correctly. 6 minus 4 is 2, 9 minus 5 is 4. Yeah, so this is the answer. So friends, again going through our step by step. So first our goal is to, we should be immediately able to see that there is a square involved and there are circles involved. Like the last question, when we looked at our last question, we noted, like in this question, that we had a square which was involved and then we have a segment which was involved. So we had our square and we had the segment which was involved. Similarly, in this particular question that we just saw, it was basically a square and circles which were involved. So let's take a look at maybe one more final question, which will be, let's see, so now this is a question number 3. Find the area of the shaded region in the figure below. So here clearly looks like we have two circles, concentric circles, and we have to find out this area. If the radii of the two concentric circles with center O are given as 7 centimeter and 14 centimeter respectively, and this angle is given. So two concentric circles, same center, one is a smaller radius, let's call it R1, the other one is a bigger radius, let's call it R2. So R1 is given, the smaller one, that is 7 centimeter. R2, which is the longer radius, that is given as 14 centimeter. And also the area, the angle of the sector is given as 40 degrees. So friends, at this point you should be able to see clearly that this will be, how do we find, so our shapes are, it's all circle, and now, so unlike the last two questions where we had square and a segment, and the last question where we had a square and circles, here we are actually looking at circles and sectors. So you should be able to see that this area that we need to find out, which is highlighted in blue, we can think of this as the area of the entire sector of the outer circle, right? That minus the area of this. So this required area highlighted in blue, we can think of this as, we take the entire area of the sector of the larger circle, same angle, right? And we subtract the area of sector for the smaller angle. So if we take this and if we subtract this out, then we are going to be left with this. And we know that area of a sector is equal to pi r square by 360 times theta. This is a formula to find out area of a sector, and theta is this angle which is given to us. That value is 40 degrees. So then what this question really becomes, so we have to calculate the first one for the larger circle. So the area will be equal to pi r square. For the larger circle, r is 14, pi r square by 360 times 40. So this is the area for the bigger circle, right? So similarly, the area now for the, so this is still the bigger circle, right? So we just calculated the area of the bigger circle. Let's focus on the smaller circle. So this is the area of the smaller circle. So this area should be, well, we are calling the smaller circle 1, R1, and the bigger circle 2. So let's call this area AR1. So this will be equal to pi, R is 7 for the smaller circle. So pi r square by 360 times 40. So now our final area, this one, which is equal to the bigger one minus smaller one. So let's do it here. So the desired area is equal to pi r square by 360 times 40 minus pi r square by 360 times 40. So clearly from here you can see that we can take, let's first get this out. So, and 4 9s are 36, 4 9s are 36. So pi divided by 9 we can take common, pi divided by 9 we can take common, and then we have 14 square minus 7 square. So here we know, if you know the square of 14, that is 196, you can simply say this is 196 minus 49, or other way you can actually think of this as a square minus b square. So it will be 14 plus 7 times 14 minus 7. You can do it that way as well. So now simply by finding out the value of this, you can find out the desired area, which is highlighted in blue. So friends, as you have seen through these three questions, and we're going to see more questions in the next webisode, that applying those three steps, identifying what all simple figures are involved. Second step, understanding that what areas we need to add or what areas we should subtract to get the desired area. And finally, finding out each of these component areas, we can solve these questions.